For grade 7, today we are going to learn chapter 3, that is properties of natural resources. So today we are going to learn about properties of air. What are the properties of air? Air is a mixture of gases. Air has no shape. Air has mass and weight. Air exerts pressure and is called atmospheric pressure and is the same in all directions. Air is affected by temperature. Air takes up space. Air can be compressed. Air regulates the temperature of the earth's surface. Air is useful as a medium for the transmission of sound. So here in this experiment, first experiment 3.1 figure, we are going to study about the air pressure. Okay, air has mass. So you can see here in the picture a straw is taken and a thread is tied in between the straw. So you have to tie two rubber balloons. Two rubber balloons are there. You have to tie two rubber balloons of the same size at the two ends of the stick. See to it that the stick remains horizontal. Now remove one balloon, inflate it. Again you have to remove one balloon and inflate it and tie it again at its original position. Does the stick remain horizontal? The stick goes down on the side of the inflated balloon. See, this stick goes down on the side of the inflated balloon. This means that the air has weight. Air is a mixture of gases. You can say that air has weight and air is a mixture of gases. Therefore, like all other matter, it has mass and weight. Now, in the second figure 3.2, we are going to learn about the piston. See here, the piston can take an injection syringe without the needle. Pull its piston and observe it as you do so. Now here, what is this person doing? You can see it is on pulling the piston. See here, on pulling the piston with the inlet hole of the syringe. This inlet hole of the syringe is closed. More space becomes available to the air in the syringe and it becomes rarefied. As a result, the pressure of the air in the syringe is lowered. Comparatively, this pressure is lowered in the syringe. Then, comparatively, the pressure of the outside air is very high. That is why, when the pulled out piston is released, it immediately is pushed off again. It is immediately pushed off in. If this experiment is repeated, holding the syringe in different positions like vertical or horizontal or inclined, the piston is found to go into the same extent in all the cases. From this, we can infer that atmospheric pressure is same in all the directions. Okay. Now, we are going to see the next experiment. Here we have to see the effect of the air pressure. What is the effect of the air pressure? So here we have to take a glass, take some water in a plastic cup. We have to take some water in a plastic cup. So you can see here water is there in a plastic cup and hold a straw upright. This straw you have to hold upright, straight in it. Hold a small piece of another straw near the upper end. Here you have to hold the straw near the upper end. Okay. Small piece of another straw. Then the first straw and perpendicular to that straw, blow hard through the small piece of straw. Blow hard through the small piece of straw. You will see a fountain water. Why did this happen? You can see here the fountain water. Why did this happen? On blowing through the straw, the air at its open end is pushed away and hence the pressure of the air at the opening goes down. As the pressure of the air near the upper end of the erect straw becomes less than atmospheric pressure, the water in the cup is pushed from where the pressure is higher to where it is lower. That is in the upward direction. This is pushed in the upward direction. And the water comes out in the form of the fountain. The more forcefully you blow, the higher will be the fountain. This straw fountain works on Bernoulli's principle. In the next picture, we are going to learn about the how does the water droplet collected outside the glass. So here what happens, we have to take ice cubes 3/4 filled. Okay, we have to fill the ice cubes 3/4 filled into the glass. So what happens here, take ice cubes in the glass. We have to take ice cubes in the glass up to 3/4 of its height. Now observe what happens. How did the water droplets appear outside the glass? Here, due to the ice cubes in the glass, the air surrounding the glass cools down. As the water vapor in this air cools down, it condenses and gets transformed into the water. It is this water that collects on the outer surface of the glass. You can see here droplets collecting outside the glass. Why it happens? The level of the humidity is different in different places. Similarly, the humidity levels also change from time to time during the period of a single day, within a day also. The level of humidity of the air is determined by its capacity to hold the water. Okay. During the night or at dawn, when the temperature of air is low, its capacity to hold the vapor is also low, is transformed into droplets. This is what we call dew. We can call it as a dew. In the early morning, you can see the dewdrops collecting over the grass. Now here in the another experiment, we can see about, in the other experiment, properties of air. So properties of air, you have to take a bottle, empty bottle, and put it into a vessel which is filled with the air. We come to know that, see what we have to do, deep and uncorked inverted empty bottle. We have to, the lid should not be there. So uncorked inverted empty bottle in a slanting position into the water in the wide container. In a wide container, we have to fill the water and put the bottle inverted into the container without a lid. So we come to know from this activity that the air has properties occupying space. We can see when we put the bottle into the water, the air bubbles coming out. You can see here the air bubbles coming out. See here, air bubbles you can see coming out into the water. Correct? So air bubbles coming out from the water. So now, when rays of light fall on this minute particle, the particles spread the light in all directions. This natural phenomena is called scattering of light. Thank you.